Investigating Matter. Welcome back to the Science Hub Escape B. In part 1 of this series, we'll be learning matter, states of matter, transitions, comparing atoms, elements, molecules, compounds, and ions, and diffusion and osmosis. What is matter? Matter is any and everything that has mass and occupies space. It is made up of atoms. There are 4 states of matter. We have solids, liquids, gases, and plasma. In solids, the arrangement of the particles are tightly packed in a fixed, regular, and orderly pattern. Particles vibrate around fixed positions but do not move freely. They have strong intermolecular forces between the particles in place, and the solids have a definite shape and volume. Here are some examples of solids. You have a diamond, a wine glass, and wood. The particles in liquids are close together but not in a fixed arrangement. They are loosely packed. Particles slide past each other, allowing liquids to flow. Intermolecular forces are weaker than in solids but still present. And liquids have a definite volume but take the shape of their container. Here are some examples of liquids. We have juice, oil, water, milk, honey, and liquefied chocolate. The particles in a gas are far apart and in a random, disorganized state. Particles move freely and rapidly in all directions. Intermolecular forces are negligible. Gases have neither a definite shape nor volume, expanding to fill their container. Here are some examples of gases. Air is an example of a gas. In balloons, you will find helium gas, which is lighter than air, which enables it to float. Clouds are special because they exist as all states of matter. Particles in plasma consist of ions and free electrons. They are widely spaced and highly disorganized. Particles move very rapidly and collide frequently, creating charged particles. Interactions occur between charged particles, but they are weaker than in a solid or a liquid. Plasma conducts electricity and is influenced by magnetic and electric fields. Examples of plasma include neon signs as well as lightning. The states of matter are also referred to as phases. Substances can be described as being in a solid, liquid, gaseous, or plasma state. When substances gain or give off energy in the form of heat or light, they're expressed as transitioning from one phase to another. Heat is gained via melting, evaporation, sublimation, and ionization transitions. These are referred to as endothermic transitions. Heat is lost via freezing, condensation, deposition, and deionization/recombination transitions. These are referred to as exothermic transitions. Here are some examples of substances that experience sublimation and deposition. Dry ice, which is also solid carbon dioxide. Iodine crystals, snow or ice in cold, dry weather. Naphthalene balls, which are ingredients present in mothballs. And so is camphor, which is an ingredient present in mothballs as well. As previously stated, matter is made up of atoms. These atoms take up space and have mass. An atom is the smallest piece of matter that still keeps the properties of an element. Atoms cannot be seen by the naked eye. They are microscopic and they cannot be broken down by chemical means. Each one has a different mass. There are many different types of atoms. There are currently 118 different atoms on Earth. 92 occur naturally while 26 are man-made. An atom is made up of three main parts. You have the protons, which are positively charged, the neutrons, which have no charge, and the electrons that are negatively charged. In the atom, the protons and neutrons are located in the nucleus, while the electrons are located in the energy level, which are also known as energy shells or orbitals. An element is a substance that is made up of only one type of atom. An element can exist as a single atom like helium, argon, and iron. These are referred to as monatomic. Elements containing more than one of the same type of atom are called molecules. A molecule is a substance that is made up of two or more atoms. The atoms can be the same or they can be different. Molecules that have two of the same type of atoms are referred to as diatomic, while molecules that have more than two of the same type of atoms are referred to as polyatomic molecules. Molecules that have different types of atoms are referred to as compounds. All compounds are molecules, but not all molecules are compounds. The compounds of substances are often written in a special way. The type and amount of atoms in the molecule are indicated in what is called a formula. These are the names and formulae of some common compounds. Glucose has a formula of C6H12O6, while ammonia has a formula of NH3. In glucose, the formula tells us that there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms that make up the molecule. While in ammonia, the molecule contains 1 nitrogen atom and 3 hydrogen atoms. Some compounds are often referred to by their common names. For instance, baking soda, which has a chemical name of sodium hydrogen carbonate and a formula of NaHCO3. Table salt is a common name for sodium chloride, which has the formula of HCl. Vinegar is the common name of acetic acid, which has the formula CH3COOH, while washing soda is the common name for sodium carbonate, which has the formula Na2CO3. An ion was once an atom or molecule that carries a charge due to the loss or gain of an electron or multiple electrons. For instance, the sodium ion Na+ indicates that 1 electron was lost. The fluoride ion F- indicates that 1 electron was gained, while the oxygen ion O2- indicates that 2 electrons were gained, and the calcium ion Ca2+ indicates that 2 electrons were lost. Ions with a negative charge are called anions. They become anions by gaining electrons. while ions with a positive charge are called cations. They became cations by losing electrons. Ions containing only one species are referred to as a monatomic ion. Ions that contain more than one type of atom are referred to as polyatomic ions. The idea that particles are in constant motion is called the kinetic theory. The term particles broadly refers to molecules, atoms, and ions. It also applies to other small entities like protons, neutrons, and electrons. It is a convenient way to refer to small entities. Diffusion and osmosis are excellent evidence for the kinetic theory. Diffusion is the movement of particles from an area where the particles are at a high concentration to an area where the particles are at a low concentration. Diffusion occurs in gases and liquids. Gases and liquids are referred to as fluids. The rate of diffusion is faster in gases than in liquids. Osmosis is a special case of diffusion. Osmosis is the movement of water molecules from an area of high water concentration across a semi-permeable membrane to an area of low water concentration. Recap. An atom is the smallest unit of matter. It is the building block of matter and it is microscopic, which means that it cannot be seen with the naked eye. An element is a substance made up of only one type of atom or multiple atoms of the same type. They are macroscopic, which means that they can be seen. A molecule is a substance made up of two or more atoms of the same type. They can also be seen. A compound is a substance made up of two or more atoms of different types. Comprehension. Fill in the table using the list of words given below. Kerosene, sun, ozone, wood, diamond, fire, corn syrup, aurora, nail, oil, and methane. Fill out the table accordingly. On the solid, you should have wood, diamond, and nail. On the liquid, you should have kerosene, corn syrup, and oil. On the gas, you should have ozone and methane. And on the plasma, you should have the sun, fire, and the aurora. Comprehension. Categorize the following substances as either an element, molecule, and/or compound. Be careful. Correct. So you have to remain mindful that all compounds are molecules, but not all molecules are compounds. And also, some molecules are elements, but not all elements are molecules. So here goes. On the element, we have N2, CS, O3, and Na. On the molecule, we have N2, H2O, CO2, O3, and CH4. On the compound, we have H2O, CO2, and CH4. I hope you got everything correct. Comprehension. State how substance A is different from substance B. Substance A is a solid. Its particles are very close together. The forces between the particles are very strong, and it has a definite shape and volume. While substance B is a liquid, its particles glide past each other. The forces between the particles are not very strong, and it has a definite volume, but it takes the shape of its container. Comprehension. Indicate what transition is occurring at A, B, C, D, E, F, G, and H. Correct. A represents sublimation, B melting, C evaporation, D ionization, E freezing, F condensation, G deionization, and H deposition. Comprehension. List 4 substances that experience sublimation and deposition. Then list 2 transitions where heat energy is gained and be lost. Examples of substances that experience sublimation are iodine crystals, carbon dioxide, naphthalene, ice, camphor, etc. Heat energy is gained via sublimation, melting, evaporation, and ionization. And heat energy is lost via deposition, freezing, condensation, and deionization. Comprehension. What subatomic particles are located in the nucleus, and which subatomic particle is located in the energy level? Protons and neutrons are the subatomic particles that are located in the nucleus, while the electrons are located in the energy level, orbital, or energy shell. Comprehension. Circle the cations. Correct. If you have the calcium, potassium, iron, ammonium, and sodium ions circled, then you are correct. To answer this question, all you had to do was to look for the positive signs. Comprehension. What is the basis of the kinetic theory, and what is diffusion, and B, osmosis? The basis of the kinetic theory is that particles are in constant motion. Diffusion is the movement of particles from an area where the particles are at a high concentration to an area where the particles are at a low concentration. Osmosis is the movement of water particles from an area of high water concentration across a semi-permeable membrane to an area of low water concentration. Comprehension. Fill in the missing areas in the table. If you have these answers, excellent! Thanks for watching part 1 of Investigating Matter. See you around for part 2. Bye!